Right, hi everyone and welcome back to Classified Part 2. Be sure to check out the first video where we looked really in depth about how the planetary system works and also the efficiency claims. Do subscribe because I can tell from the last video that 70% of you weren't subscribed. When I'm talking to brands trying to get high-end parts to test like this Classified hub, it just gives me a bit of extra clout. So please do click subscribe, it really helps me out and it helps you bring the content as well. Now I am riding outside today to try and get some training in whilst doing this video, just like a steady zone 1 gravel ride with a few saucy bits thrown in, which I hope you'll appreciate me getting muddy for. But just to recap, in this part 2, we're going to look at 3 main things: the install of the equipment and the bill of materials and what you get sent, or what the dealer gets sent and what they put on your bike, a general ride review about how it works, how the system works, how do I rate it. I am reading off my script because I forgot to bring my print out, which I printed this morning and left it on the printer. And part 3 is going to be my efficiency test and all the conditions of that test. Now, you know, oh, you didn't test this, you didn't check this, you'll be surprised. Wait for the conditions, I'll list them all out. There's a dog coming, hang on. All right, now not really a problem for the consumer, change gear. Not really a problem for the consumer, but a problem for Classified, I think, is just the inventory is absolutely massive. There's such a massive parts that they have to ship every customer or every dealer for a customer's bike, because the through axle lengths are different. There's specific torque reaction arms which brace the torque of the sun gear when you're in the reduction ratio, and it's all quite messy until the bike industry really support this. So there's 3 lengths of through axles. There's numerous threaded ends that you can fit onto those through axles, because all bikes have different thread pitches in the dropouts. And that torque reaction lever that braces the reduction gear reaction torque against the flat mount brake isn't actually ISO tested in the factory. So when bikes are ISO tested in China and all the frame factories, it's not part of the ISO test. That load case, that torque reaction going into the brake mount, is not part of the test. Now, I'm sure it's fine. However, on my bike, where the torque reaction arm has been butting up against the bolt, which is what it's supposed to do, it's actually started to dig in and it's left a dent on the reaction arm, which is normal, that's what you want it to do. But the ISO test for the flat mount is a cyclic fatigue loading scenario, but it's not tested for that case. So it's a little bit of a dirty secret. I don't think there's going to be any problems in the market with that, but if Classified want to get this through as like a system for everyone, they really need to make sure frame builders are testing against that load case. Because when you pedal in the reduction gear, all of your pedaling torque is reacted by the sun wheel. And as we looked at in the last video, that sun wheel is locked to the central shaft. And if you didn't have that torque reaction lever, the central hub shaft would just spin inside the dropouts. Now, some of that torque is taken by the clamping of the hub and the end caps and the friction between the end caps and the dropouts. But anything left over is taken by that torque arm. I don't know why they just didn't make that torque arm twice as long, because then the force would be half as much, and just brace it on the front bolt to reduce the torque a little bit. It might look a little bit more messy, but I think it would be better. Now, this is another thing for them, inventory wise. The through axle with all the wireless electronics in it that's receiving the signal from the handlebar and contains the battery, that should be detachable. Because when they send you the 3 through axle lengths, or send the dealer 3 through axle lengths, they have to put the expensive electronics and the inducting coil as well in the center of the through axle, in every single axle. There's the potential for damage, like the through axle with all the electronics does stick out quite a lot. The lever, I mean, it does stick out quite a lot, and it's very likely to get damaged in an accident. Classified say that's not really a problem, but it'd be so much better if it was detachable, like a, you know, DT Swiss detachable Allen key for a through axle. But that brings me back to all of these things. None of these crappy little levers on through axles are getting the axle tight enough for me. You really need to be putting 15 Newton meters, 12 to 15 Newton meters on a through axle. And these spindly little levers, whether it's the Classified one or the DT Swiss removable one, they just aren't long enough to get a good torque on. If frame builders were to support this system, all they need to do is put a square slot in the dropout, and that would react any torque from the center shaft of the hub. So you wouldn't need that torque arm if you had some sort of keyway or square slot dropout instead of round kind of recesses in the dropout. But yeah, if you made it like 15-16 mil square, made the end caps on the hub square, then you don't need the torque lever on, but you need a special bike design to do that. Thank me Classified for patenting that one. I've already done it for you. Now this is another commercial thing, the wheel choice I think is quite limited. Although Classified like to say they've got really, really high-end wheels, I don't think they're up to scratch with the really kind of boutique, lightweight stuff out there. I don't know why they don't license out the hub shell, which is a dead part. It doesn't have any, you know, special internals in it, just the hub shell. See, that's absolutely buttery smooth. Why don't they license out that hub shell to Extra Light, DT Swiss, I mean, what kind of already is with DT Swiss, but Hope, Chris King, and then you can pick whatever wheel you want, whatever rim you want. Even the Chinese makers like Windspace and Fast Sports and Yo-Yo or whatever could just make the hub shell with the female spline in there, and then it just opens up a whole massive wheel choice. And I actually think a lot of people are put off because of the Classified wheel choice not being what they want. With this system you have to ride Classified wheels, and whilst these rims are great, it would just open up the market to them if they just license out that female hub spline, and then you could have any wheels you want. And to be fair, I'm riding finally the Classified front wheel, but there's no reason at all to ride the Classified front wheel. For me, I would just sell the clever part, the internal gear module, plug it into a licensed hub shell, and off you go. Now I want to talk about the cassette briefly. It's super duper light. When I first got out of the box I was like, oh no, they've made an aluminium cassette, that's not going to last. It was amazingly light, and I couldn't believe it was made of steel, and actually did a cheeky hardness test on the back of it to find out what kind of steel it could be. And I'm not going to disclose that because it's classified, but super impressive. However, there are quite a lot of really rough machining marks around it. I don't think it affects the efficiency or the chain noise that much, but it doesn't look very nice and it soon wears in. You may notice the odd bit of rust on this cassette. It's not from the cassette, it's from my 105 level chain. As it gets wet and the wax washes off, it just rusts. Right. Now finally, there's no dedicated area for the shift button. You can see at the moment I've got it by my right thumb, and it's just a really good position. You can see it's so easy to shift, reduction, 1-to-1, reduction, and it's held on with the 3M VHB tape that I use all the time for projects. But yeah, it really needs better integration if they're going to make this a thing. You can splice it into Di2 if you're happy to cut and solder, having this extra button. And the other thing about the button, which we'll talk about in the ride review part, is that there's no feedback to what gear you're in. So sometimes when you're absolutely blowing out your ass on a climb, your heart rate's at 190, you can't figure out, you just go, oh, I'll just go for the reduction ratio. You press the button and boom, all of a sudden you're grinding away in the big chainring mode. You're finished, but you suddenly just grind to a halt. So all that needs is just a rocker button, an up and a down on the button. That would solve all of that uncertainty. And you might think, how can you not know what gear you're in? Well, you know what it's like when you've fucking smashed off your ass up a climb. Even when you've got a front mech, you sometimes just press the lever. You'll know what I mean, your brain doesn't really work. So it'd be good to have either a visual feedback or just a two-way button, a rocker button, and up and a down would be really good, instead of just a kind of binary button, because you know it's so smooth, I don't know what gear I'm in. But yeah, there's my script. Crack my screen. Buy me a new phone if I got some more subscribers. No, it couldn't. It's subscribers don't really matter, but it helps when talking to the brands. So yeah, I'm in bottom gear. Look at that, beautiful. Anyway, ride review. How does the gear changing perform? Well, absolutely savage. It's instant, it's silent. The chainring setup I've got on this bike is a 39 front chainring. At the moment, it's not even a narrow wide, and it's not giving me any problems at all. It hasn't come off since I set it up 1x. And I must admit, when I had it set up 2x for the efficiency tests, which we'll come on to, it was a bit mind-boggling. The 44 possible ratios were a bit annoying. I was like, I could be in a small chainring, 1-to-1, or small chainring, reduction ratio, and then the big chainring, 1-to-1, big chainring, reduction ratio. It was all a bit mind-boggling. When your heart rate's 190, it was just too much choice. But now I've put it 1x, all the gear changing is done with my right hand. I've got the button set up here, and obviously the rear changing is done here. It's just so nice. And the gear changing so far, I've probably put about 1000k on this system, all off-road. Absolutely amazing, to be honest. Now, when you ride the bike on the road, you can feel the planetary gearbox. You can feel it when you're in the reduction ratio. Now, depending on how in tune you are with your bike, you may find it feels a little bit, not rough, but it feels like riding a bike with a slightly worn chain. Or if you've ever ridden a tandem with a juggernaut on the back, you've got that extra chain in series before your power goes to the rear wheel. It just feels like there's another mechanism there, which of course there is. You've got the chain drive plus a gearbox when you're in the reduction ratio, and you can definitely feel it. When you're on gravel like this, you can't feel it. You don't know if you're in the reduction or the locked ratio, and actually that's its own demise because you forget what gear you're in. Tarts that like a high engagement buzzy rear hub to let all the other tarts in the forest know that you're coming and you're shredding, you'll be very disappointed with this hub. The ratchet is not the quickest pickup and it's very, very quiet, and I really like that. I like quiet free hubs. It's actually really silent. All you can hear is the chain really. But yeah, freewheeling drag is quite high. See, stopped already. Limits of one by again. It doesn't unlock one by because you're still going to have a very compromised chain line in both ends of the cassette, and obviously you can tune the chain line with where you put the front chainring and which way round you run the front chainring. Now, not had a single miss shift, of course. Everything's been flawless, mechanically flawless. Can't complain. Weight. So the wheels, as I mentioned, they're not the lightest. I think they can take a lot of weight out of the wheel system. They have just released the new gravel rim, which is not this one. This is the shallower one. But still, the hub shell, the dead part, is heavy. The front hub's pretty heavy, and the really annoying thing is the lock rings are proprietary for the discs, so you have to use their external spline lock rings, which you use a Shimano BB tool. I didn't actually have that Shimano BB tool when putting the front wheel on this morning, so I knocked it round with a hammer and a punch. But don't tell classified. But the front brake's still on. It's got those little nails on it to keep it attached, but yeah, and discuss the elephant in the room, which is what you nerds want to know, and that's the efficiency test. Teleport, 3, 2, 1, bang. Oh, there's a toe overlap. Fuck, it's lethal. Right. So we're back in the warm now, and it was all going so well, wasn't it? Water ingress. The rear through axle got waterlogged after that ride. After cleaning it with just the hose pipe, some soap and water, we got water ingress. Really, really disappointing. So let's have a quick look at that. Quick update, I'm on the ride now after that big ride where I was in the forest filming all the voiceover for the video. First ride after. And after washing the bike the other day, I've got it out. As you can see, it's spanking clean. And I noticed the classified system wasn't shifting. Sorry about the wind noise, it's very windy out today. Pulled the battery cover off and I've blown most of it out now. Come on, focus. My hands are so cold I can't feel them. Yeah, soaking wet inside there. Quite a lot of condensation on the cap and it's very wet inside there. And as I blow it, there's just loads of water coming out. Now, I don't know how the water's got in. The O-ring on the battery door is fine, I think. And then between the shaft and the axle, there's a load of silicone, which gets kind of worn away. You can see a bit of the silicone there. And I think the water's got in through there. Not good. I think it's completely dead. The battery door's always been closed from day one since I charged it, never had a problem with that. The O-ring's intact, so the only other path of ingress can be either between the two clamshells of the plastic moulding or down between the axle and the plastic handle. Like I said, I don't know if this is a pre-production unit or a marketing unit that is no longer used in production. I've sent it back to classified and they're inquiring as to how the water got in, but hopefully it's just a one-off. Now, before we get into the testing and the test conditions, let's have a quick look at the masses, because I haven't mentioned that yet. And if you're going to buy the system, are you looking to gain weight or are you going to lose weight? Well, it very much depends on what you're taking off and what you're putting on. But for me, I gained 60 grams. So this is the breakdown very, very quickly of what I took off. Now, in this left column, this is my 2x setup. These are all the masses of the things I took off. And in the right-hand column are the masses of everything I put on. So you can see here from just looking at a few things, I'm not going to go into this too much, but the classified cassette is very, very light compared to the 1134 Ultegra cassette, which is an absolute chunk. And I took that off. My chain rings are quite heavy as well, because it's the it's not 105, but it's the sort of non-105 series 105, if you like, from a couple of years ago. Those chain rings are pretty heavy. The chain ring I put on is exceptionally light. It's not even a narrow wide chain ring. It's a 39 tooth inner chain ring from Shimano. I think it's an Ultegra, super, super light. I've never had a chain drop with it. And I've ridden down some pretty gnarly off-road stuff. So if you've got a wolf tooth, one by narrow wide chain ring, it's going to add a bit more weight. But for me, overall, the total's about 60 grams heavier with the classified setup. Now, if you're taking off low-end components, maybe your classified setup's going to be lighter. If you're taking off a load of Dura Ace components, your classified setup is going to be heavier. That's how it is. 60 grams, don't really notice it. The really, really heavy part of the classified system is the bit you can't get around. It's the hub gear module, so the bit that plugs into the back wheel, and the torque lever, for me, that weighs 500 grams. The wheel set weight, that's without the hub module. Now, test conditions. You can pause the video here because this is really nerdy. This is how I tested the efficiency. Now, normally I don't like doing outdoor tests. You kind of laugh at them when GCN do it because there's too many variables. But here, really, the outdoor test or the climbing test is the nitty gritty. It's the bread and butter of, is this system going to make you slower? Is it going to make you faster? So I did an outdoor test on a climb, 25th of October, climbs about 1 kilometre long, 10% average-ish, approximately 10 to 11 kilometres an hour. So it's quite a slow one, it's quite a grind. But the important thing is the gradient is very, very consistent. So the cadence and the power is constant throughout. 8 degrees C, and I did 8 times 5 minute repeats at 330 watts. Now I was pretty knackered by the end of this. So in total, it was all done within about an hour and 20 minutes, about 1,100 meters of climbing. But we're not using Strava to measure the time because that's absolutely inaccurate. And there are 2 cases to test. So the 50 by 30 in the reduction ratio. So that's using the large chainring on the 2x setup in the reduction ratio at the back. So that's using the classified planetary gear system, and then the 34-30, so the inner chain ring and the same gear on the back, and a locked 1-to-1 ratio. Now, when you do this calc, like the effective gear ratio, so the cadence is basically exactly the same. Now, look at the test conditions. Like I said, you can pause it if you don't want to listen to this because it is quite nerdy. Reps were done in the AB fashion, so alternating, totaling 8 laps within 1 hour 20, 1,100 meters of climbing. System weight remained constant. So if I ever drank a sip of water, I'd go back to the car and refill it. 30-minute warm-up to settle any temperature effects of either the head unit and the power meter electronics. That's the main thing. The riding line, now this is the important one, the riding line up this climb, because there was a few switchbacks, was within as close as I can keep it to a 40 centimetre track as I'm going up the climb, and I'll put in a bit of B-roll about that. Right, this is the first lap of the 1-to-1 ratio, so no classified engaged. Obviously I'm still using their hardware in terms of the hub and the bearings, but no planetary system engaged. We are 1-to-1. Now all I've got to do is match the same power. And of course, the line choice. So I'm taking the same lines through the gravel, so not to affect the rolling resistance and the vibration losses on my body. Any meters gained or meters lost on the climbing line is going to make massive adjustments to the actual time. No out the saddle riding to eliminate any tyre slip. It was all seated, all constant power. Now, this is important, this bit. The normalised power is almost the same as the average power for all runs. So that goes to show there's no coasting, there's no spinning, there's no light pedalling, there's no out of the saddle power spikes. It's constant power and cadence. We're not measuring aero effects, so that's not really a problem. This is 10 kilometers an hour, so aero effects are basically negligible. But the wind on that day was nothing. You're in the trees. It was a dead day. It was a perfect day to do this kind of test. And the tyre temps and pressures and stuff, well, obviously that's kind of settled when I got out of the car by the 30-minute climbing warm-up, and they were rechecked after the test. There was no measurable pressure difference, and any differences should be taken into account in the AB alternating fashion anyway. The timing accuracy, I estimate that to be about 0.1 of a second because I was using marked start and stop lines, and I was using the stopwatch on the lap timer on the Garmin. So we're absolutely not using GPS or Strava data for this test. The power meter has an algorithmic auto zeroing every time you descend and you coast, so pretty happy with the reliability of that. And the temp variation over the test was 1 degree C. Now, before I told all this conditions to classified, they were a bit, how can I say, edgy about my test method. But when I put this to them, they kind of went, yeah, that's pretty good. And in this test, I must stress, we used an energy calculation method. So the little effects of different power on every repeat and different times on every repeat, that's all negated. That all comes out in the wash when you measure energy. Because if you move something up a hill, you're giving it the same gravitational potential energy. It's the same whether you do it quickly or whether you do it slowly. So the product of power and time is energy. So if we would just calculate energy, instead of just going, oh, well, that run had a bit lower power, that run had a couple of watts higher power, and kind of second guessing whether that makes a difference. If you just times power times time, you get energy, and the energy should always be the same no matter what the power. So this is just the raw data, but we'll come back to this in a minute when we look at a few nuances. And let's get into the graphs. It's much easier to explain. Now, the top lines here, in this, I don't know how to describe this type of green. I would say it's a more of a minty green is the reduction ratio, the 0.686 ratio. So that's using the classified gears in the back. That's using the planetary gear system. And the mossy or sage green lines are the locked 1-to-1 data points, and that is when you're using the rear hub basically in a one-to-one fashion. It's working as a normal hub like we established in the last video. So that's not using any planetary gear systems. And from a quick glance, it looks like, yes, oh my god, the locked ratio, so not using the planetary gear set, is faster and it uses lower energy. So the top graph, let me just recap, is the pure timing climbs. So you've got the time of the climb down here, you've got 5 minutes. From about 5 minutes 10, we got down to about 5 minutes 6 on the fastest run, up to about 5 minutes 13, so about 300 seconds. But obviously there are small power differences between each run of about half a watt or a watt. And if we just go back to the graph previously, or the chart previously, we can see that the standard deviation of the power was, for the reduction ratio, was about half a watt, and for the locked out runs was about 1 watt. So I mean I kept to 330 watts pretty damn good. But that comes out in the wash, because if we do the product of power and time, we get energy or work done. And so actually this is the main chart we want to look at, this bottom chart. So you could say that the energy, well, it should be the same for everything, and any gaps will come out as efficiency. That is the efficiency difference. You could say that, oh, when it's locked out, you're not using the reduction ratio, it's more efficient because look, this line is lower. However, if we look at this second point here on lap number 2. On the second lap of the one-to-one, so small chain ring, no classified. But the classified just did the fastest lap yet, so there you go, clearly not inefficient. The reduction ratio run was actually faster than the first run of the locked out ratio, and that's the same in energy. So already there's a discrepancy of the trend, because yes, you could say that, you know, if you line them up lap by lap, that the locked ratio is faster. Actually it wasn't. There's 3 out of 4 where it's faster, and then there's one crossover here where the reduction ratio energy was actually lower than the first run of the lock ratio energy. But in general, I had faster runs when it was locked out, but only by about 1%. So let's look back into the raw data. Now, I agree that, well, this is not even the raw data. This is condensed raw data. Now, I put my hands up. This is quite geeky. But first of all, just look at the time differences. So the time on every climb was about 5 minutes 10. The mean time difference between the reduction ratio and the lock ratio is about 3 seconds. So that's about 1% mean time difference. And the standard deviation here on the times alone was about 2.5 or 2 seconds. So we've got about 1.5, 1.6 times signal to noise ratio, which is what we want. We established in the last video we couldn't take any data from this if our overall time differences were lower than the standard deviations of all the runs alone. So we've got that greater than 1, that signal to noise ratio. But if you're doing this as a lab test, anything lower than a signal to noise ratio of 10 would be thrown away. But this is outdoors, it's very, very hard to do, even by keeping all those conditions the same, even by riding in a 40 centimetre track all the way up the switchbacks. It's the best as I can do, and I'm pretty happy with this test. Probably one of the most important and accurate tests I've ever done, taking into account all the considerations. Now, if we look at the energy side, because the time side, like I said, is affected by the power, but if we look at the energy side where everything should be the same, here we've got the same runs. I've just laid it out again. We've got the number of seconds for the reduction ratio, number of seconds for the locked ratio, and then we've got the energies for both. Now, these should be the same. Any differences should be highlighted as an efficiency change. There's someone at the door. Oh, fucking hell. Let me pause this. Now, kudos if you're still with me, because I appreciate this is getting really, really geeky, but we're nearly there. We're nearly finished on this whole data thing. I can't wait to get this done. So if we look at the energies where the small power differences are taken into account, then the mean energy difference is about 1100 joules, which I'll have you know is about the same as 0.25% of a banana. Our mean energy difference is greater than the noise, so that's good. And as an energy difference, it's about 1.1% less efficient than the lock ratio in my test. Now, if we apply that 1.1% loss to the 99.8% efficient one-to-one ratio, which is taken from the white paper like in the last video, I get an efficiency from this test, from this hill climb test, of 98.7%. Now, I was really chuffed with that. I was like, first of all, that's really quite efficient for a drivetrain. Sorry, this is not the drivetrain efficiency, this is the efficiency of the hub, I must stress. Now, I was quite impressed with that. I was pretty close to their 99 point something % claim for the reduction ratio. So I sent this data pretty quickly without all the raw data and without all the test conditions, and they were very, very defensive. They were a little bit put out that I hadn't achieved over 99% efficient, and I thought, well, that's a bloody good result, and considering it was outdoors as well, and there's lots of other things going on. Until I sent them all the conditions like we went for, and then I think they were quite happy with it in the end. But I must stress that they wanted to note that my test probably wasn't so efficient as 99 that they were claiming because of the cross chaining. Now, because I was riding a 2x setup, They're claiming that because I was doing the reduction ratio in the 50 tooth chainring on the front, so the outer chainring, that I had quite a crossed chain back to the 30. Now, yes, it's not ideal as a 1x setup, because with the 1x setup, I could tune the position of that chainring. However, that only applies to this test in the 30 tooth. If I was doing a 5% gradient and I was using a smaller cog at the back, if I tuned the chainring position in a 1x scenario, then I'd be worse off somewhere else on the cassette. So I must stress that this 1x thing is there's still a limitation of this classified system because of the chain line, and it's proven by this test that Classified sent me some data where actually they'd use a 50 tooth chainring with a slightly better chain line, and they actually had a better efficiency than using a locked scenario with a smaller chainring because the chain tension was 45% lower, and that chain tension can account for a very large efficiency gain if you lower the chain tension, because also, like I mentioned in the last video, you lower all the radial forces on the bearings involved in the hub and in the bottom bracket also. So you can actually improve, according to Classified, the efficiency of the system using the reduction ratio, but it's very, very sensitive to chain line. And yes, I could move the 50 tooth in or buy a narrow wide 50 tooth and move it the other side of the crank spider, but then I'm going to penalise myself when I'm using other gears at the back. So you can't use that as an excuse. At some point it's going to be cross-chained. If you're riding on the flat and you've moved the chainring inboard and you're using like the 11 tooth on the back, you're going to have a very, very badly cross-chained chain in the 1-to-1 or the reduction ratio. So I don't buy the chainring argument. This is the data from my test, and I think 98.8% is bloody good. But yes, I do hold my hands up. With a better chain line, I probably could have improved it and maybe even gone faster. However, I'll put in some pictures here. The chain line of my setup was really, really good because I managed to move that 2x setup as close to the frame as possible. So close, and Yolio say, you can run a 50-34, but I managed to get it a bit closer by reducing some of the spaces that I put in. So close that it's almost rubbing the chainstay, so I couldn't have gone it much closer with the 50 on this bike. On a road bike, yes, but on the gravel bike, you can't go much closer with a 50. So I'm not really buying that argument about the chain line thing. It depends on the bike, and also, like I said, if you're changing gear at the back, your chain line is going to be worse somewhere else. However, one thing I really like about the Classified system is that you gain time when you're shifting, because with the front mech, you have to there's a little bit of coaxing involved. If you're dropping it really quickly, how many times have you seen riders come into the base of a climb on a Sportive or even a pro race or something? They slam it into the front chainring, they drop the chain. Or similarly over the crest of a climb when someone's attacking, or you're in a road TT and you want to punch into the big chainring over the top of a climb, you do have to coax that front mech a little bit, particularly if it's mechanical. Not so much with the i2, but it's not a foolproof system. With this, it's foolproof. It's bang, bang, bang. It's on the button. You do save, I would say, 3 to 4 seconds on a climb. So that's some seconds at the bottom of the climb shifting down and some seconds gained at the top again shifting up. The shifting is just phenomenal. Like, I really, really, really do rate it. Now, hopefully the water ingress thing was a one-off, but will I be sticking with this? 100% on the gravel bike, I'll be sticking with it. I just like this, I say simplicity. There's a lot going on in this hub and in the electronics, but when it's installed, the user experience is simple, and that's what I like. So I really hope you enjoyed this Classified series. I can't stress how important it's been for me to do this test correctly and accurately, and I hope I've done that. Yes, I could go and do it again with a different chain line and I might get a different result, but you can only have one chain line at once on a ride. You can't go and change it during a ride. Now, it's been, I think, some of the most important testing I've ever done. I think this is a very big step change in cycling engineering, probably as big as when Di2 first came along. I do really like the system, and I'm going to keep it on the gravel bike. So please do like and subscribe. Like I mentioned in the video, it helps me get more high-end stuff off brands to test, and kudos to Classified. They let me present this data without any inhibition. They haven't tried to stop me publishing it, and I do think my efficiency test results are pretty damn good, and I'm happy with it. So cheers, and I'll see you in the next one. So hope you enjoyed that, motherfuckers.